Okay, hello guys, welcome to AP CSP Unit 6 review. So today is a short video about simulations. We'll be exploring simulations and randomness of simulations and creating simulations on code. So before we want to go into code simulations, we gotta know what is simulations and how they work in other scenarios. So simulations are virtual models that mimic real-world systems or processes to study their behavior under different scenarios. So by replicating key features and interactions, simulations allow for experimentation and problem solving in a controlled, risk-free environment. And we can really split simulations into four steps. So this would be modeling reality, variable control, risk-free testing, and data analysis. So they in simple are basically they first step is characterizing the real world phenomenon, so like traffic flow, weather patterns, or disease spread. And second, variable control. This can modify inputs to observe how change affects the outcome. And for risk-free testing, so this eliminates the potential dangerous costs or ethical concerns of real-world testing. And at last, the data analysis. So this generates data that can be analyzed to identify patterns, trends, or insights. And now let's take a look at when simulations happen in different places like physics, astronomy, and health medicine. So when they appear in places, they offer insights into complex systems, so they improve understanding and allow experimentations without physical risks. So, for example, for physical simulation, the it replicates the physical phenomenon and helps scientists or engineers to explore and understand the concepts of the test theories. And examples will be particle physics and quantum mechanics. So I'm actually interested in quantum mechanics, so I will explain more about it. So this is when simulating quantum systems to explore phenomena like superposition, entanglement, or quantum tunneling. So if you're interested in this, you can go search up more information about this because it's actually really interesting. So as I said, the simulations can help experimentations in conditions that are difficult or dangerous to create in lab. So this would be a really beneficial way to do experiments for physics and other fields. And for astronomy simulations, so this is when you model a celestial phenomenon and cosmic system, and this is aiding to research and educate about the universe. For example, formation of galaxies and stars. So they can use simulations to see how galaxies, stars, and planets from over millions or billions of years how they work, and how they change over time. And for orbital mechanics, so this models the path of planets, moons, and spacecraft to study gravitational interactions or plan missions. And for health and medicine simulations, so they can help training diagnosis and treatment development. So example, surgical training, so they can use VR or AR to train medical professionals in complex procedures and letting them risk risk patient safety. So this means that they don't have to risk somebody's life to practice their experiment. No, surgery. And there are also epidemiology and drug development. So they are all related to, related to simulations and use simulations to do further research for their careers and fields. And now we can take a step forward into looking how simulating randomness in code happens. So simulating randomness involves generating values or events that are unpredictably or they're usually unpredictable behavior and so you don't know what the results are going to be. So an example would be like rolling a dice, flipping a coin, or a natural phenomenon. So in computational context, this is typically made using algorithms designed to produce pseudocode random numbers or events. And let's look at some key concepts in simulating randomness. So first there is randomness. So this is just referring the outcomes that occur without a predictable pattern. So rolling dice, deck of cards, and something like that. So I explained before. And then second, we have pseudocode random numbers. So this is when computers use algorithms to simulate randomness because true randomness is difficult to achieve computationally. So the numbers are called random numbers because they are deterministic but appear random for practical purposes. And third, we have true randomness. So some systems use external unpredictable process like radioactive decay or atmospheric noise so to generate true random numbers. So some example include hardware random number generators. So one of the codes I want to explain that has randomness is the dice roll. So on the first step, so we import random. So this gives us the code to ability of doing random, generating random stuff. So and the second line, so here, so this is list. Uh, here you guys can see the numbers. So what they mean is they list defining like the likelihood of rolling each face of the die, and the sum of the probability is like the number it will generate. And so you can see getting so the chances for like for example for phase one it has 10% chance, for phase two it has 20%, for phase three 30%, and for four and five each has 15%, and for six has 10% chance. So there are six phases, like as we all know in the dice. And then in this code we call the bias dice roll function 10 times, so this simulates the 10 rolls of the die and it would show the result of each roll. So let's see, and it will be different due to the probabilities of each phase. So okay, you guys can see, so here's 5 5 1 2 5 1 1 3 3 1. Well, this like it's like pure luck, but logically you're supposed to get the third phase the most because it has 30% probability. We can generate again. So see, this is normal. You have like one, two, three, four, five threes. So this is like this is predictable because it has like higher chances of getting this number. After taking a look at how it works in code, I want to explain how it is different types of it existing in programming. So there are RNGs and seeding RNGs and shuffling and sampling. So you can see them here, but they're not that important part of the CSP, to be honest. So after exploring the random simulations, we can create a simulation ourselves. So we can model this as a race between two competitors. So there will be a tortoise, so this he'll move at a constant speed, and a hare. But he'll move faster, but occasionally stops to nap. Well, this is like a story from Turtle and the Rabbit. You guys must have heard that from your childhood. And our program will be will update the position of both races step by step and display the progress in the race. And then at the end it will declare the winner of the race, and then the program will stop. And so here we can see the code. So we can split this into different parts to analyze it. So first is the initial setup, so which is this part. This would be defining the constant like race distance, speed, nap frequency, and nap duration. And this initializes the variable for positions and steps. So as you guys can see, so here we have the race distance, the speed, so a nap frequency and nap duration. And we've listed all the side information there. You guys can look at it. And then we can look at the simulation loop. So this loop would so it's here you guys can see. So this loop continues until one or the other wins the race. So it when they hit the finish line. So the tortoise moves at the constant speed in every step, but the hare checks if it needs to nap. If so, it stays in the position of the it is at that time and then takes a nap duration. And at every step, the program prints the current position of both racers, and it will indicate when the hare is napping and will tell us. And at the end, it will declare the winner. So one or the other will hit the end line. So let's check the code. So here you can see. So the race begins, and so step one. So the tortoise is at 1 and hare is at 3, and then yeah, you can skip. It's just normal addition. It just goes at a constant speed for turtle and for the hare. But here you guys can see. So here it stops and then it starts napping, and then it naps, but the tortoise would move. And then you guys can see it repeat this process until one or the other hits the finish line. So at this point, hare wins. And because of the data we set the hare, it moves 3 and the tortoise only moves 1 and the nap frequency is too small. So we can assume that there's basically no chance for the tortoise to win for this race. And to say why is it useful, so this demonstrates basic programming constructions. So it has loops, conditionals, and variables, and this is also simulating real world scenarios. So it's pretty simple logic, so it's pretty easy for us to understand how it works using the code. And that's it for today. Thank you for watching, and wish to see you next time.